Okay, to do a trig limit, a trig definition for a derivative, you're gonna need to know a couple things. One thing you need to know is a limit as theta goes to 0 of sine theta over theta is equal to 1, and we proved that by the squeeze theorem. The other one you need to know about is the limit as theta goes to 0, and I'll go through this one over here. Cosine theta minus 1 over theta is equal to 0. Let's go through that. So again, this is the one you really should know. And let's write this one down to make sure you can understand that this is true. So theta goes to 0. And this is going to be, I really screwing up with the notation over here. We'll get to the limit in a second, though. All right, so let's put this down. Limit theta goes to 0. And what I'm going to do is multiply top and bottom by the conjugate. And the conjugate is going to be cosine theta plus 1. So I get theta cosine theta plus 1 on the bottom. On top, what do you get? You'd get cosine squared theta minus 1. Let me make sure that's true. If I multiply the conjugate, you get cosine squared, then you get plus cosine minus cosine, and then minus 1. And I'm going to kind of look at that and wonder what to do with that, but I guess I could do the limit now, all right? And before I do that, I want to point out the top. What do you mean to do the limit now? I need to recognize the top as something. And what's that going to be? Let's be really careful about this. The sine squared plus cosine squared is equal to 1. So cosine squared minus 1 is actually equal to minus sine squared. And this is over theta cosine theta plus 1. All right? Almost there. Let's write this down. Limit as theta goes to 0. I'm going to write it as, minus sine theta over theta times sine theta over cosine theta plus 1. Well, the first limit's easy. It's just the number 1. I mean, that's simple enough. And this guy's limit off here also pretty easy. What are you going to get? You're going to get 0, because as you go to 0, sine goes to 0. And the bottom would go towards 2, so it's going to be 0. What's the limit over here? 0, as specified. Anyway, these two need to be known. And I would say, for the most part, before you enter an exam, they probably should be written down, so just in case they pop up, you know what they are. All right? So let me go to the limit now. Now, when you're doing a limit over here, you're just writing it down. And what are you writing down? The definition, and this is a definition. And then you got a problem, by the way. The problem is I don't see either of those limits there. So what you have to do is expand the sign. And if you did that, the sine of x plus h is sine x cosine h plus sine h cosine x, and then minus sine. All right? And again, I'm looking for these things over here. That's what I'm looking for. So I'm kind of looking around, and what I noticed, let me get my eraser out. I move things around a little bit, right, to see those things. And the first thing I moved around was I took these two together. Let me get my red pen out. I took these two together, and I put them together over here. And then, this guy over here I put there, all right? And then I split it into two different limits. Where the two different limits going to be? Well, let's be careful about this. Make sure I wrote this down correctly. And I want to circle this thing for you. I'm going to say this is one of the limits over here. The denominator is h, of course, and that's the other one over here. All right, so what I do, I factored the sine x out. And what he left off with cosine h minus 1 over h. So I see that. And the other one, I just noticed it was sine h over h times cosine x. And what do I know about this? I know those limits. All right, they might have different letters in them, but I know those limits. For example, I know this guy's limit. We just did that before, by the way. That's 0. And I know this guy's limit. It's just simply 1. So what are you going to get over there? 0 times sine x, which is just, there's no sine x's anymore. And then 1 times cosine x. Easy peasy, lemon squeezy, so to speak. Get my eraser out again. What are you going to get over there? You get this, simplify it, get cosine x. As expected, by the way. We know that. We certainly know the derivative of that. Thank you.